Hello and welcome to the Flutter event, to the Flutter Festival in Stuttgart. My name is Manuel. I'm one of the organizers of this event, and I'm very happy to welcome you today to the first event since the pandemic. First of all, I would like to say hello to you who have come to us on site. Glad that you're here. I hope you feel comfortable with us and have had a good time with us so far. I'm also pleased that so many guys, remote participants, are interested in this event. Hello, guys. Today, we are guests at MWAY, obviously, because we are organizing the Flutter meetup in Stuttgart. I like to give you some facts and figures about Flutter at MWAY, which you should have heard about. Maybe you will need it later again. We've been using Flutter since here in 2018 and have used it successfully in around 20 different customer projects. Officially, I'm in the role as HR manager at MWAY. That's why I like to stress that we want to further strengthen our team with Flutter developers. So if you're interested, you're welcome to get in touch with us later, and you can talk with us. My colleague Jana and I will be there for you. Next, I would like to tell you something about today's agenda. We will hear two interesting Flutter talks today. My colleague Christof from the Flutter team wants to start with his talk, which is the more beginner-friendly talk today. After that, we will have a little short bio break, around 5 minutes, to refresh. And then we look forward to have here Pascal Walsh, who will take us to a more advanced part in Flutter. Pascal, thanks for being here in Stuttgart. It's so great to have you. After that, we will do a question and answer session about the talks or general questions about Flutter. And it's worth sticking with us until the end, because we'll be giving away our popular Flutter swag in our lottery. We will do a nice little online quiz together. If you want to take a chance, you will need your smartphone, or the remote attendees, it's also okay to do it via browser, but I will explain it later in detail how it works. Okay, if you have any questions during the talks, raise your hand, or if you're on your computers, you can write it in the chat. Our colleagues Ervis and Daniel from the Flutter team will be then happy to answer you. Now, this is all from my side. I wish you a lot of fun with this Flutter Festival here in Stuttgart. And now handing over to my colleague, Christof, giving a nice applause. Thank
you, Manuel. So let's start with the cross-platform mobile development with Flutter. This is a beginner's talk. I will make a holistic introduction. We will learn how Flutter can bring the same code base across several platforms. We will learn how it got so successful, and also the main part of this presentation will be some live copying. So we will see step by step how to make a Flutter project. And in this practical way, I think everybody will get, that has not been working with Flutter yet, will get a good overview. So yes, and as Manuel already told you, when you are at a remote part of our Flutter Festival, you can always ask questions inside the chat and we will answer it. And if you are here on site and have any questions, just raise your hands and I will answer it. Okay, the first time I got in contact with Flutter was in year 2018. It was part of my master thesis. The topic was state-of-the-art cross-platform mobile frameworks. I compared 6 different cross-platform mobile frameworks in this thesis. And the 2 most promising ones, React Native and Flutter, were compared in more detail. And already in this year, Flutter had a lot of potential. And since my master thesis, I became a real Flutter fanboy. Yes. So what is Flutter? Yeah, a cross-platform front-end framework. One code to rule several platforms and operating systems. It's nowadays it supports iOS, Android, browser, Windows, Mac, and Linux. But how does Flutter achieve this cross-platform compatibilities? At first, we have our code base written in Dart. Dart was, before Flutter times, a pretty uncommon language. Originally, it should replace JavaScript on the web, because JavaScript has some disadvantages, especially regarding object orientation and type safety. And Dart was intended to replace it, but as we all know nowadays, JavaScript's object-oriented replacement is TypeScript. So Dart was not that popular, but that changed as Google decided that its new cross-platform mobile framework depends on this technology. Okay, we have our code base with Flutter code, and we are some kind of putting it inside the framework. And with the help of the framework, it can be compiled to native binaries. And we get a native-like app. This can then deployed with the app stores. And here we have our device with a native-like app being rendered by a rendering engine that is inside Flutter. So we have no bridges, we have no language boundaries. And also we are not using with Flutter the real native elements. Flutter renders the pixels of its own UI elements on its own with help of the engine. This is another figure that can explain this functionality. On the right side, we have the platform, our smartphone, with some text and a button who listens for events. The UI here is defined by a widget composition. So, for example, the text is one widget, and this white container is a widget. And also inside our Flutter app is a 2D rendering engine based on Skia. Skia is a graphics library that is also cross-platform. It can support, depending on the operating system, different graphics backends, for example, OpenGL or Vulkan on Android and Metal on iOS. And then inside our Flutter app, there's also the Flutter Runtime. Flutter Runtime is responsible for executing our Dart code, for garbage collection, and also for threading. And our Flutter app transmits a canvas, transmits UI data to our platform. And when we are, for example, pressing on our button, we are transmitting from our platform events to the Flutter app again, and data can be processed. Flutter was, with this rendering engine approach, pretty successful in the last years. They are nowadays market leader in cross-platform mobile development. Here we see a survey from JetBrains from year 2021, and we see the only cross-platform mobile framework that was capable to rise its market shares in the survey was Flutter. All others were stagnating or were decreasing. And here's also another statistic showing that already in the mid of 2019, there were more Flutter-related Stack Overflow questions than React Native-related Stack Overflow questions. But probably this also refers to the fact that a lot of React Native questions can be answered in React.js questions in Stack Overflow. But we see it's still rising. But why became Flutter market leader in that short amount of time? Or no other cross-platform framework? On the one side, it's of course due to massive marketing budget that Google invests. Google wants Flutter to be really successful and to be widely used, but there are also other aspects that make this a really nice, especially developer experience. Yeah, it's really stable and efficient. During my master thesis, as I wrote a little bit more detailed app with React Native, I had a lot of problems with building. It didn't went that well, probably due to the bridge that React Native uses. React Native uses real native UI elements, and this can lead to problems. But Flutter has its own environment, has its own engine where the pixels are getting rendered, and so the developer experience is really stable, efficient, and feels good. We also have really great tooling. Later on, we will see some examples in the live copying session. And linting and code completion also works really well. We have the best performance in cross-platform development, but it's still weaker than native performance. When we are developing an app with Android native, then we have much less time during startup in comparison to Flutter, because we have to set up the entire engine whenever the Flutter app is starting. The UI elements are pretty beautiful by standard, and also they are the same across different operating system versions. When we are developing with Android native or with React native, we have, I don't know, between Android 8 and Android 14 and different UI elements. But since Flutter uses this rendering engine approach, we can have the same style and look across different platforms and operation system versions, but Flutter automatically adapts some stuff between the platforms. For example, when we have an Android app, the navigation and routing does work as we are used from native, so that a new page is popping upon the old one. And when we have a Flutter app on iOS, we have, for example, we have in the routing the sliding animation and sliding behavior as we are already used to in native iOS apps. And the best thing is the high productivity and flexibility, and also the fun factor that is behind this framework. Flutter team has its own UX section, people that are only responsible to create the best developer experience and the most efficient developer experience. And I never heard of any framework that is really technical that has its own UX designers to make a pleasant experience. Yes. And also we have the full flexibility. So with Flutter, you can realize any conception that the designer gives you can be realized, but nevertheless, you can work with the standard UI elements and get pretty fast to success. Okay, so this was the theoretical part of the presentation. Now I will get over to live copying, but I also want to ask you if you have any questions about this part. Okay. No questions. Then let's get practical and let's make our own first Flutter app, the elusive battery controller. And I want to show you the final application. I'm switching the screens. Okay, here on the right, we have our elusive battery controller. When starting the app, we are reading out our battery level that is on the device right now. And then to give us a better feeling, we can increase it, and also the color adapts. And if we want to prepare ourselves for lower battery states, we can also decrease it. And we have a back to reality button. Of course, in reality, this does not make really any sense. But the reason why these features are inside this app is that we have a clear state management by adding battery levels and decreasing it also. Another aspect is that we have some data handling depending on the percentage that is on the battery. The UI is adapting with some background color. And we are also having a connection to the native world, to the native part of Flutter. I will explain it on base of Android. So we are really accessing the battery data from Android operating system. Okay, now let's start. I will go to an entirely empty project here. If we want to create a new Flutter app, we can use the Flutter CLI. I'm just entering here Flutter create, I don't know, new app, for example, pressing enter. And a folder structure is being generated. So this will be the start when you are creating a new Flutter project. I will show you the most important folders and files. Here inside lib, we are developing our application. We are writing our Dart code. When generating automatically a new Flutter app, the really well-known counter app is being generated. It's just a standard app that always is being generated when you are starting a new project, but we don't need it because we want to start from scratch. Then we have, for example, platform-related folders. Here, Android, iOS. Here we can define platform-specific functionality and also access to the operating system. And another important file is this pubspec YAML. Here we are defining our version of the framework, but also external dependencies. The pubspec YAML is comparable with the package.json, from NPM development. So here we can just add, for example, here Flutter Lins version 1 and any other package being provided by the Flutter community, and then it's getting installed and can be used for our app as external modules. Okay, so now I will go back to the presentation, because before we are starting with the implementation of our app, we will start with the UI. I want to clarify what exactly widgets are and how they are organized. They are organized in the widget tree. So here we have our elusive battery controller, and the related widget tree does look like this. So we see it's just a tree structure, as we already know it, for example, from HTML or XML, and this tree structure is defining our layout. For example, here we have a text elusive battery controller, and it's being wrapped inside a padding widget. So we have some spaces here, and this padding widget again is being wrapped inside a column widget, and the column widget can have several child widgets so that we have a vertical orientation between our UI elements. But how exactly this will work, we will see now in practice. So let's go to the code. I'm changing the branch to initial. Yeah, also the source code can be looked at on GitHub. I think Manuel has posted it into the chat so that you can also access the elusive battery controller. Okay, now I'm triggering a hot restart, and we see a really raw, ugly app. Does look like this. Okay, what is happening here? Here inside our lib folder, we have a file called main.dart, and this file has a main method. This is the entry point of any Flutter application. And we are passing a widget to our app. Here, it's a custom widget, a stateless widget. And every widget has a build method. And inside this build method, again, a widget composition, a widget tree can be defined. Here we have at first a material app. This is a widget just saying, yeah, it's a mobile app. It's with material design style elements. And then we have here a text, and it's rendered not really in a beautiful way. So we need to wrap it in a so-called scaffold. A scaffold is a layout element that defines a material page. So inside the scaffold, we can define on the one side the content of any page that we have inside our mobile application, but we can also define the app bar, for example, or floating action button that can be on top of screen. Yeah. So now I need to wrap this text element because it needs to get a new parent, and this is a scaffold. And Flutter has a lot of nice tooling. We can say here wrap with widget, and then a opening and closing bracket is automatically generated around our text widget here, and then we can define what kind of widget we want to use here. It's a scaffold. And the scaffold has a body, and this body should contain our text. Now the text is over here. That's not that nice. We want to have it centered. So we can again wrap the text widget with another widget, here wrap with center, and now it's in the middle of the screen. And what's really important to know is that every single widget is an object, and the definitions here are constructors. So here we are generating a new center object that has several parameters that can be passed in its constructor. For example, a width factor or a height factor, and of course a child. And then we are passing the other widget, the other object that's also created with help of a constructor. Here with this, this constructor uses a string data, so what's inside the text, and also other functionality, other attributes can be defined, like text style and so on. And this is the child of the center widget, and the center widget knows, oh, I got a child. I want to set it on the screen by centering it. Okay, but now we want to build up this UI. So let's see how it's working. At first, I want to create a new file being called battery view. And inside here, I want to generate a new custom widget, a stateless widget. Here. Also, we have some nice automatic code generation. We are calling this widget battery view, and then we have to import the material library we want to work with. And now I want to copy paste stuff from here, the scaffold and the text and so on, to our newly created custom widget. And then we want to call this widget as child, as home child from the material app. Battery view, importing. So nothing changed, but on the UI, but our structure has changed. And then we want to create our battery. For this, I will copy something. Yeah. Okay, and I will also add this battery border width. Okay, yeah, okay, it has no real nice color. I think the color here, background color, I don't know, colors.red. So this is a container defining the body of our battery. We have this container has a specific height, 130 logical pixels, and it has also a width depending on the width of the entire screen. This is achieved with MWAY.offContext size width, and then it's being multiplied with 0.9 to create some spaces between the edges of our screen, and then we are also subtracting the battery border width. It's just some styling. In the battery border width, this variable we have over here is also put inside the border as width. So we have these 15 logical pixels on our border here, and we are also defining a border radius so that we can get some nice rounded edges. And now we want to add the pole of our battery. So we need another container to the right. So I'm wrapping this container with a row. A row can take several widget children and align them horizontally. this is the first child, our battery body. Oops. And now we need the battery pole. Yeah, height 50 pixels, width, also the battery border width to make it look nice. And color is white. And we see here the row is aligning the two child widgets horizontally beneath each other. But now we also want to add our battery level on top of this row, on top of this battery. This can be achieved with a layout element called stack. It's similar to frame layout in Android or position relative, position absolute in CSS, if you know it. And here we have several children. The first is our row, and the second one is our text that is showing the certain battery level. So the first one being rendered is this row, and then on top of it, since it is a stack layout, our text. And this text over here has some styling. On the one side, color, font size, font weight, and we can also adapt the string here, the 64%, we can say 69% saving, and immediately we get the UI feedback on our device. Okay. Then we can wrap this stack again into a column, because we also want to show some interaction elements down here and also a headline on top. So at first we say column main axis alignment center, because we want to have our elements in the center of the screen, and then I can add the headline on top of it. So here is again a headline with padding and with a string value and also some styling. And we can add at the bottom the buttons. Okay. Here we see we have a column inside here. And Flutter, fortunately, always gives us hints where a closing bracket is referring to, because otherwise it would be really difficult to detect, for example, where does this padding bracket start, where is it opened over here. And we also have some nice tooling stuff inside our IDEs that can help. For example, I installed rainbow brackets with this colorful brackets that also improve and also help on which opening bracket is referring to which closing one. Okay, now we have here still an error. The floating action button needs a foreground color. So I'm defining a background color, sorry. I'm defining this color over here with a hexadecimal value that is referring to green. Now I can add this background color to our scaffold, and also, our icons here have this color, so they are green too. So, and what I want to show to you now is how can we, for example, make out of this battery again our own widget and copy its content. This is also pretty easy. So we are going to our stack layout. The stack layout is the farthest top widget element of our battery itself. And now we can press, for example, in VS Code command dot, and we have some hints on what to do with the stack layout. And I'm say here extract widget, and I call it battery widget, pressing enter. And now Flutter automatically generated a own widget here. And this widget can also get some attributes, for example, the percentage. So I say here final int battery level. Then I need to adapt the constructor here. I say add final field format parameters. And this battery level also needs to be required. and then can be put inside here so that from the outside our percentage can be manipulated. Battery level inside the string with the $sign, we are saying that the upcoming string is a variable name, and after this variable name we are again just rendering the string, in this case here the percentage sign. Okay, but now we need to add the content here. How much battery level do we need? For example, 21. Now it's adapted, and now we want to duplicate this battery, but have another battery level. So we are just copying our battery widget and giving it another battery level. And it's even possible to automatically generate several widgets on base of a data source. So for example, if you have an array or a list with several battery levels like 12, 18, 89, then we can map over it. Here it's a battery level. And then we can say for every single battery level inside this data source or this array or whatever it should be, we want to generate a battery widget using this battery level. I'm saving it and we see, oh, we have an error here, comma, and we see, zack, we have 3 different batteries being generated out of this list array. This also helps us massively to separate UI and logic. Okay, this was all about the view. I'm gonna change the branch. Now we see the original version. Needs to be what restarted. Now again, we will only have one single battery, but here we have an error. Okay, in this branch, I also added an external package. So I added here Google Fonts and the provider package inside the pub/spec YAML, and I need to install them. This is also possible with the Flutter CLI. I'm writing Flutter pub/get, and now all the packages being defined in the pub/spec YAML are being downloaded. Okay, and now here we see we also have a new nice Google font style, and this is our UI. Do we have any questions regarding making UIs with Flutter? Yes.
Thanks for the presentation. I have multiple questions. Maybe they are relevant, maybe they are not relevant. But first of all, do you have any solution for colorblind users?
So for what users?
Colorblind users, because not everyone has like a healthy view. So if someone is colorblind, how your application deals with that?
I did not consider it. To be honest, I just made some color reaction to different battery levels. But how would you? Does anybody has a suggestion on how to deal with it? Or
sorry, I think we have to explain it for the audience. What was the question because the microphone?
Ah, okay. The question was on how to make this application applicable for, hopefully I understood the question correctly, for people with color blindness. Yeah, okay.
Because they cannot see the contrast, you know.
Yes.
So, the question is that how your application is adaptable in different devices with different sizes, like mobile phones and tablets, and how?
It's expanding automatically depending on the size that is available. Here we see, for example, inside the battery view, we have a, is it here? We are defining the width of our battery on base of the screen size, and then multiplying it with 0.9, so that 90% of our screen size is being filled with this battery view. And for example, the stack layout uses a position filled widget for the text, so the text will always be centered inside our battery. So it's not depending on how big the screen ratios is. The the application automatically adapts here. Unfortunately, I cannot show it because I have here a real device where screen ratios cannot be changed.
Nice. The other question is maybe for now is too far away, but you do a lot of alignment manually, and I think, do you have any plan to do it automatically, some artificial intelligence? Because I'm from data science background,
okay.
and I'm thinking it's too much manual work.
But then you have the full control over it. If you have a designer that wants exactly one kind of view, then you have the full control of it. I don't know if is it even possible with artificial intelligence to make stuff like this. I'm just an app developer. I don't know.
Yeah, for sure. But as a developer, I mean, it's nice to think about like having artificial intelligence helping to somehow increase the
Okay, yeah.
What I can say is that GitHub Copilot, so that AI coding assistant by GitHub and OpenAI, works really, really well with Flutter. So you can, for example, just add a comment like enter a battery level widget here, and it will AI auto-complete the widget for you. So that's already working very well.
Okay, thank you.
Yes.
Wouldn't it be an answer for the first question because of the color blindness to define a separate special theme data so that you get a more contrasted theme?
Yes, yes, but you need the color values that have enough contrast that also can do not refer to or do not have any consequences for color blindness. Yeah, I did not think of this in this application.
Answer.
Okay, yes?
Defining special, they do a lot of semantic widget stuff in Flutter, so you can pretty much make it easier for people with a disability to probably watch that stuff. But I don't look at that stuff. But I don't know if they actually have stuff for automatically determining a theme.
Automatically determining a theme.
It was basically just try to help her.
Okay. Yes. Yeah. We can. Of course, we have theming inside Flutter, so we can basically define what colors should be used and so on. But this is not part of this presentation because then it would take too much time. Okay. So this is all about the UI functionality in Flutter, and now we will go to the business logic. As we've already seen, we can combine variables and styling and UI with both, but it's not a good idea. One should try to separate UI and business logic as much as possible. And so I'm proposing this kind of app architecture for our elusive battery controller. At the bottom, we have a repository. This is some kind of portal to external data. So our repository is creating a method channel to the Android operating system and can therefore read out the battery level of our device. Then we have the change notifier. This is comparable to a controller in the classical model view controller model. We are taking this battery level coming from our operating system and processing it. So we take the int and make a, for example, string out of it, and also adapting the colors of the background. And then on top, we have the view that we already developed. And the view and the change notifier are being connected with a model. Now again, with the dependencies between the layers, our change notifier can call methods inside a repository, and the methods can return values. The change notifier can read out the model, so our color or our battery level, and can also change it. But our view can only call methods of the change notifier and can not alter anything at the model, because it should not do anything with the model because it's only UI, it's not a controller, but it can call methods on our change notifier, and this change notifier can then again altering content of our model. And now we will take a look at this. At first, we will make the repository, so reading out the battery level of our operating system. I'm going to change the branch here to repository only. I already implemented it here, and I will show it. Yeah, at first there is a new folder structure. We have the battery domain. The battery domain contains the battery view, but also the battery repository and the battery change notifier. This refers to our to our architecture model. So change notifier is empty, but here inside the repository we have some functionality. Can I make this smaller? Here we are creating a method channel to our operating system. So we want to trigger a method of Android code and get the information from Android code to our Flutter application running in its own engine. With this call, we can trigger Kotlin code on our native side. For this, we will take a look at the Android folder, because inside here we have Android specific functionality. What's also really nice with Flutter is I can press here right click and then directly open it in Android Studio. Okay. Need to create a new desktop here. So yeah, here we have it. Here, unfortunately, I cannot make it. Oh, I can make it bigger. Nice. So here we have our Android main activity. So when executing the app on Android, this is also our starting point. The main activity is inheriting the Flutter activity, and the Flutter activity can start the Flutter engine inside an Android environment and start our app. Here we are overriding a function from the Flutter activity, configure Flutter engine, and here we are creating method channels and are registering possible method calls. So on our Android side, we have the method channel. Yeah, this is the name of the method channel, but also are calling the invoke method, get battery level. And then on the Android side, it's shown, oh, we got a message from our method handler, from our method channel. It's called get battery level. Okay, now we are calling inside Kotlin code, inside Android native code, the get battery level. And here we are reading it out, returning it, and then are calling result.success battery level in Kotlin. And then the battery level is getting transferred to the Flutter part of our application. So, and now this repository, this battery repository, is only for presentation purposes directly called. It's a static method, battery repository, static get battery level, and I put here at the back to reality button. Here we have a on pressed callback. So when pressing it, we are directly accessing the static method of the battery repository, and then inside the repository it's getting printed. Let's take a look at it. Debug console. I'm pressing the button over here, and here we see 36%, just like here on the top. Now we want to create another layer, the change notifier controller layer, that is getting the data from our repository and preparing it for the UI. Okay. Oh, this one can be closed. Go in here. So first of all, we are working with an external package, with an external state management package called Provider. This is the most used state management package in the Flutter world. There are also many other pretty nice ones, but for this presentation, I decided to use the most used one. Yes, but now we take a look at how to make state management with the Provider package and State Notifier. So for this, I'm gonna create a new battery change notifier inside here. So we have the battery change notifier that is inheriting change notifier. And then we also want to pass the battery repository that is reading out the data from our operating system. And when the battery change notifier is created, we are injecting the battery repository inside here so that we can work with a single instance of the battery repository to retrieve data and then prepare it for UI. Okay, but our battery change notifier needs to be registered inside the application. For this, we need to provide a change notifier provider. We can make it, for example, here inside our main Dart. So, and every children of this change notifier provider can get access to our change notifier, to our business logic. So we say, okay, material app, web with widget, and then we are passing our change notifier provider. We need to import the library and also import here the battery change notifier. Here a new instance of this battery change notifier is being created, and we are also passing a battery repository instance on app start time. This can be ignored. Okay, and now we want to define the model inside our battery change notifier. The model depends on the certain battery level and also on the color. So, yeah, that's not final. Here we have the battery level and also the background color hex value. Here it's the yellow color. And now we want to use this data on our UI, but at the same time, we do not want to make it changeable from UI. So I declared those variables as private by adding this underscore. Whenever you are adding this underscore in front, at the beginning of a variable in Dart, it's marked as private. So this cannot be accessed by our UI, but we can make it accessible, or we can make it visible with some getters here. Now the UI can retrieve the background color and also the battery level, but it cannot alter it. Now let's go to the UI and let's make it retrievable. So here, here's, for example, our certain battery level, and now we are accessing the change notifier by using our build context. Yeah, with the help of context, our battery view can look up the widget tree. Where is our change notifier being registered? Ah, there he is, and then the data can be read out. So. Here again, we are using this $sign notation to directly passing variables inside a string. Now let's say context.watch, because we want to watch the changes of our battery level. Then we need to define what should be watched. We want to watch the change notifier provider and battery change notifier provider. Battery change notifier, yes, and then we want to call the function. It's not doing it. We need to import the provider package. Now we want to not call the function, but want to access the getter with battery level. Saving it, and we see now we have the battery level, the -1 being defined in the battery change notifier. And the same now gets adapted with the color. Here we can again say context dot watch battery change notifier, and then here we have the color, background color hex value. So now it's getting yellow. But does it? No, it does not get yellow. Okay, of course we need to wrap this only the raw hex value. So we need to wrap it inside a color object. Now we are creating a new color object with this certain color hex value. And this hex value refers to yellow. Okay, now we have our connection. Now we can read out data from the battery change notifier, but now we also want to alter it with functions. So especially we want to read out the original battery data, the original battery level from our operating system. So yes, here battery repository, get battery level, we need to make it non-static. So whenever this function is getting called, we are retrieving the battery level from our repository, our portal, where we are getting the new data. That repository could also be a database or could be a REST API to get data from the internet. And then when it's not null, we want to set the private battery level with the new battery level from repository. And mainly we want to do it at the beginning of our when our application starts. So here when we have created a change notifier, we also want to call this function of this change notifier, but we also want to call the function when pressing on the back to reality button. Where is it? Here we have something. We can say context.read. It's typical with the provider package that you are using the watch keyword when you want to show something, because you want to listen for changes and re-rendering stuff when the value changes. For example, the battery level is getting increased. And we are using read when we are inside callbacks, because when we are pressing the button, we do not need to listen or to watch for anything. We only need to read our change notifier provider and then calling the method of this instance. Yes?
How does this not show?
Sorry, I did not understand.
If you know it's possible to add a delay or something.
I think it's not directly. You need, I think that you need to adapt some stuff inside your change notifier. You can say, oh, a new value, and before we are emitting the new value, we want to wait 500 milliseconds or something like this. But this needs extra code. This cannot be defined in the watch function itself. Or it does no? It's not possible. Okay.
I think we are.
Okay. So now we are calling here our battery change notifier, and then we want to call the method set original battery level data. So when pressing on the back to reality button, we are getting our battery level, and also when we are restarting our app, this function is called at the beginning, and then again we have the 61. Okay, and now finally we want to add logic to make to change with our plus and minus button the color and especially the battery levels. Okay. So we're gonna copy a function to change battery level function. Here we have a increaser. This increaser takes an integer. When pressing the plus button, it's +10. When pressing the minus button, it's -10. And here we are taking our current battery level and then adding the increaser to it, and then call notify listeners, so that all the variables that are watching know, oh, we have a new value, and Flutter knows that this and that stuff needs to be re-rendered so that we can see our new data on the screen. So let's call this change battery level inside our plus and minus button. Now we want to call again context.read change notifier and also change battery level. Here we are, I removed, it's the minus button. So here the increaser is -10. So it's more like a decreaser than an increaser. And then for the plus button, where is it? Here. We want to add +10. Okay. Now let's see if it works. Yes, the battery level is getting adapted, but the colors are not being adapted yet. For this, I will copy paste another function inside our change notifier. And whenever a new battery level is being set, we are calling the set background color on base of battery level. So when the battery level is larger than 100, we are showing a red color. When it's larger than 70, a green color, and so on. And now when I change here the buttons, the color is adapting. And now we want to make some smooth transition between the colors, because when you're animating colors, you always get some nice transitioning effect. So let's try it. We can go to our container over here and say, container, please become an animated container. And then we have to add a duration. So how long does the transition take? So duration, milliseconds, I don't know, 600. And now, when any attribute of the animated container is changing, for example, the background color, it's being interpolated in the time being defined inside the duration. So when we have a hex value of, I don't know, 5,300 for yellow and 10,000 for red, it's being interpolated in this time, and so we can get some nice transition effect. I show it, I press it on plus. And you see it, have you seen it again? And it's making some nice transition effect, and it was really easy to achieve that. Okay.
Sorry?
Yes?
Why do we need this transformation? Why is that important that colors change when the battery gets full?
The duration, but the duration is needed.
What is the importance of this task? Why do we need to change the color when the battery gets full?
It's only for presentation purposes. So I wanted to, when we would only show the single number over here, we would only show the real number being retrieved from the repository layer, but we also want to show here to adapt the current state, so not only retrieving the number from the repository, but also adapting the state, the color, due to the number over here. I mean, this whole app does not make any sense. If it would make sense, it would be a really nice business model, but unfortunately, it's not that possible. It's only for purpose. Its only purpose is demonstration, making an introduction for Flutter on status handled, on how to structure a Flutter app with this layer model, and also on how to work with the widgets. Yes? Okay. Yes. Are there any more? Yeah?
In your day-to-day work, what state management do you use? Or is it provider or something else?
Oh, block. The nice block, the hottest state management tool of all time. And block has many advantages. It has incredibly good documentation, and also the states are really, it's really easy to follow the different states and the state changes, and also easy to write tests, but it's a event-driven state management, and it has some concepts that are not 100% usual. So I thought for this presentation, let's take the most used state management package provider. But I assume that in some years, Block will be the state management #1 in the Flutter world. Yeah.
I also think that the most important question has not been asked yet.
Okay.
Why did you not use 42 as a default?
42? Yeah, that's really sad. You are right. This is a bug. Yeah.
So you read the battery level of this Android device, right?
Mm-hmm.
Are you sure that you can read the battery level for every other device, as an example, a Linux laptop?
For this, you need to adapt code on the Linux folder. Right now, here is no Linux folder, but let's assume we want to read out the battery level of the Windows laptop. So we need to adapt some code inside the Windows folder, and then we can code there with Windows native language. I think it's C or something like this, and there we can retrieve the data from the operating system. But when making it like this, like we've done it here in this application, we would need to code retrieving battery level for every single platform again. But in reality, in practice, you have some packages. Someone has already done this for every single platform. So you're only importing the package, and then it works nice, and you don't need to do anything on your own. The only reason why I've shown this is to show the connection between native platform and this Flutter engine, this Flutter environment where it's running. Yeah.
The application that you write works on Ubuntu also?
No, because we would have to write extra platform-specific code for Ubuntu, but it does work on iOS, because on iOS there is also a function in Swift code that is reading out the battery level. If you remember, we wrote some platform-specific stuff inside Android. We said, oh, here, let's open Android. Here's the Android folder. And then we had here the main activity. And inside here, we are retrieving the battery level with Android code, and then passing this Android code back to the Flutter part of our application. And this would also apply for Ubuntu, for example. You have to write your own Ubuntu code. At least for this app, we would need to write our own Ubuntu code, retrieving the battery level of the Linux laptop, and then passing it at first passing it to our repository, our entry of the Flutter app, then handling the data, and then showing it inside the UI. Okay. I also prepared unit tests, but I think that now the time is over. Unfortunately, no unit tests for today, but now we will make a mini break, 3 to 5 minutes, and then Pascal will take over the presentation. Thanks for your.
Welcome, everyone. I'm Pascal Walsh, and I'm a Google developer expert. This does not mean I'm working for Google. I'm more or less working with Google. Basically speaking, we work about Flutter and going to meetups like this. And I get from them a lot of information. I can talk to the developers of the Flutter team directly, and that's why I'm a Google developer expert. But I'm not working for Google. Instead, I'm working at an agency, a Flutter agency, and I'm also working on a small startup. Let's quickly talk about that, because if you have a Flutter application, you want to use Wiredash, because with Wiredash, you can get direct feedback from your users, from your QA team, from your customers, I don't know. So with a few lines of code, you can integrate the Flutter SDK, which is completely written in Dart, and rewrap your application and make screenshots of your application. People can edit some more context to these screenshots, and you get all this information for free, basically. So check out Wiredash if you haven't yet. I'm also working for Phantom. I'm the CTO there, and my job is basically to overlook all of our development teams. We're currently 15 developers. We have 4 product teams, and my main job is basically preventing bugs, preventing mistakes, and also make sure that if we write code today, it works in the future. And the only reason or the only way to make sure that code we write today works in the future is by writing unit tests and by also using continuous integration, continuously testing if everything is still working. So now you know something about me. I want to know something about you. Please raise your hand if you think you are yourself a developer. That's great. And please also raise your hand if you wrote a unit test this week. Oh, that's good. That's good. Great. Some have not written unit tests, and one reason for this could be that writing unit tests is quite hard. And today we want to talk about functional programming, which makes writing unit tests super easy. I think everyone who wrote a single test, the first thing we learn is how to test a single function, like putting an input in, getting an input out, checking if it's valid. And that's the whole concept of functional programming, because functions are so easy, we should use them more often, and they are also easy to test and they cannot break. Let's talk more about functional programming and the topics you won't learn today. So if you ever watched a talk on functional programming, you might have heard about either, task, monads, functors. I don't actually know what they are. I don't use them in my daily functional programming world. I actually use pattern matching and things like that, but we are not talking about this today. Instead, we want to talk about the very basic, and that's pure functions and also immutable data structures. That's the core basic of functional programming. And I want to show you two cool concepts, that's first-class functions and what are high-order functions. We'll come to that later. We want to do all of this in Dart. And if you have read the ECMA 408, which is actually the standardization of the Dart language, Dart is defined as an object-oriented programming language. And if you compare it to other languages these days, like Swift, Kotlin, those are all hybrid languages. They as well are object-oriented, but also are functional. They have some functional elements in it. Not Dart. They claim not to have any functional properties. They are just object-oriented. Okay. Functional programming works in any language, so this is not a big problem for us. If a language has functions, we can use functional programming. Let's see what we can do with functional programming. I want to show you an example here. We have this application which just shows some data in a data row or in rows. We can sort this data. For example, we can sort it by price, we can sort it by rating. And that's the task for today, how to implement this. And you can already think in your mind, if this is the thing you have to implement, how would you do this? How would you actually write the code that sorts this thing? Basically, if you click the rating label here, that changes the order. And if you press something else, that order will change. Think about it. What data do you need? What do you need to actually draw this UI on the screen? The first thing when I saw this problem was like, okay, I need some data, products, great. I have a list of data, cool. Also, I have to know the sort order. Is it ascending or descending? And I have to know the sort field. Should I sort by price or should I sort by discount and so on and so forth? So with three properties, I basically can draw the whole screen. The sort order, of course, are defined as enums here, and the sort field as well, because we are just limited to 4 columns. We also have an immutable object here. This is the product, but it could be any object, could be just an interface. Let's assume this just works. This is our product. It doesn't matter for our example here. Okay, now what happens if we actually tap on the price label? If we tap on the price label and the price label already has an arrow, the arrow should swap. If we tap on something else, that thing should be selected. So here's the code for that. We have some label with an inqual to get the click effect. And in the on-tap callback, we compare the field. If it's the same field that's already selected, we flip the sort order. If it's the other field, we change the sort order back to descending by default and set this as a field. And this is a fully valid implementation for this. And even with functional programming in mind, I would not change this. This is set, this is fine, this works. The tricky part is we now have to update the list of products because we changed the order or we changed the method on how we should order the products. Now we actually have to sort them. So what could we do? We could use built-in functions from Dart. For example, the list already has a sort function. That's great. We can use this. Also, Dart has the concept of comparables. We can implement the compare to function to compare two objects, in this case, strings and doubles, and just compare those. And this is how we implement the sort function. Pretty naive implementation could look like this. If this discount field is active, we call the sort function, and then depending on if scanning or dress scanning, we call the compare to function on a.discount and b.discount, and in the other sort order, we reverse, we switch A and B. It works, that's fine, and if we write the whole thing down, that's our complete solution for actually sorting the product list. And this works, that's fine. The problem with this, it's not very functional. And if you have some functional concepts in mind, you would write this very, very differently. And I will show you today how. Before, basic concepts. Functions. Functions come in different names. Sometimes I call them today lambdas, sometimes I call them closures or methods or callbacks or routines. It's all the same, it's just functions. They have some input and some output. That's it. They are all functions. Even if they are top level or anonymous, and there can be predicates or high order functions or first class functions. All functions, it's all the stuff you already know. If you know functions, you know all of them. This, for example, is a function. And think about the possible outcomes. So what happens if you put like 20 cents inside? What could be a possible outcome? We can draw this basically in a table. So for all the possible inputs, we have an exact output. And that's pretty cool, but only if this is our whole program. What if I change the one line? What if I introduce a global variable into this program? Can you now call what the output of that function is? Actually, it could be anything. We don't know because we don't know if the global variable is used at all and what properties this global variable currently has. This global variable is now suddenly also a possible input for our function, and this changes our output. And it could not only be that, it could also change the global variable. So by introducing global variables to your program, you make every function in your program add another parameter to every function. That's another reason why I hate singletons, and especially if they are mutable, because it makes debugging very hard. It could change anything, basically. Let's talk about pure functions. And this is if we don't have any global state, if all the inputs for our functions are defined as parameters, and all the outputs of our functions are defined by the return value. And they are great because they have no side effects. So side effects are basically like calling some static method or calling some global variable and so on and so forth. We don't want side effects because then our function is very predictable. We also don't want to mutate our inputs. So we can mutate an integer, but if you put a list inside that function, we should not mutate it. Instead, we should return a new list. When we have a pure function, we get the same result for the inputs we put in. So if you put in a 3, we always get the same results. And that's cool because we can also cache the results. Think about some very heavy function that takes like multiple seconds. If we know this is a pure function and we know the input, we can cache it up front. That's pretty helpful. And that's actually something in a pure functional language the compiler can do for us. A pure function is pure if it's not using pure, if it's only using pure function in its body. If it's using an impure function, it's not pure anymore, obviously. And the test if a function is really pure is if you can replace this function in your mind with a lookup table. Even if that lookup table is gigantic, that's a pure function. Okay, for today, I only want to work with pure functions. And let's talk a bit more about, oh, I said all this already. The next thing is, this works very well if you're using immutable data structures. So as I already said, if you put a list as parameter inside, that list usually is mutable if you're using Dart. Don't use this, use immutable data structures. Only this way our functions are actually pure. Speaking of immutable data structures, what are they and what are they not? The first one is a list, like we know it from Dart. We can call the add method and add a new element to this. This is bad, this is mutation. We shouldn't do this. The best practice is whenever you want to change something, create a copy and mutate the data while doing so. The same is true for not only for lists and some common data structures. This is also true for classes rewrite. If I have this user thing, this user object here, I should not be able to actually set the email address after I created it. Instead, I want to create a copy, get a new instance back with the changed data. And this helps a lot while debugging, because inside that method, if once I call this copy with method, I can still compare, oh, what was it before? What is it now? And if you have a mutable object, you don't know what the value for the email address was before you actually set it, that email address again. To use immutable data structures, you can use the freeze package, which is a code generator for basically immutable objects. It also has unions and stuff like that. But if you want to have immutable objects, please use freeze. If you want to have immutable collections, you can use the kt. If you are familiar with Kotlin, then they feel very natural to you. Otherwise, you could use fast immutable collections, great library that basically brings collections in Dart to the next level. If you want to learn more about immutability, this is very helpful. Watch a YouTube video of mine from the Flutter School. I will talk about immutability there in depth. So now we already know what functional style means. It means avoid mutations and avoid side effects. No global variables, no mutable objects, always create copies. Let's continue and go back to our example here. The first code smell, at least from a functional perspective, is the mutation at top. The sort method actually mutates the list instead of returning a new list. And we can change that right away. Let's extract a sort products method. And this sort products method needs a lot of inputs because, or basically all our free inputs, because we want to make it pure. We put in a list of products, we put in the sort field and the sort order. And with that, we can rearrange the things on a copy and then return a new list, a new object. What I'm using here is in the first line, I create a copy by calling the toList. This just creates a new list with the same elements. Then I call the sort function we had before, because I'm using the standard Dart sort function. I have to mutate with that object, but that's fine because at the very end, I return an immutable view basically on my list. So the outside world, the function that's using the return value of this function here is not able to mutate the list I returned. Fine. The next big thing we want to do is basically remove this compare to thing. And before we do this, I want to tell you about high order functions. High order functions is a function that takes a function as a parameter or returns a function. I want to only cover the first one, passing in a function into another function. How could we do this? Imagine this function which returns only products that have a rating higher than 4. Okay, now the question for you, what if I want you to change that function and add another function that should return a rating higher than 3? You really have to copy paste that whole thing? No, you don't have to, because the only thing we actually care about is this one here. The rest is boilerplate code, not very special. So we extract parameters. And the easiest way to do this, just to solve this problem, we could add a double parameter like the min rating. And then I call this function with 3 and 4, and I have my desired results. Fine, but that would be too easy. Let's do it a different way. Instead of injecting parameters like values, we can inject functions. And products.rating rate of 4 is a function. It returns a Boolean. So we can replace this with a function that returns a Boolean. I call this here a predicate because that's how we do it in a functional programming world. And by doing so, I can reuse the getProducts function, put in different parameters for basically this filter step, and I can reuse it however I want. I can change it from rating to price. I can do whatever I want just by extracting functions instead of pure parameters. This is all built in into Dart. We don't have to actually use a for loop and use an if statement. We can use the where function, and if you have a list, you can use the where function, put a parameter in. So yes, Dart actually has some functional programming interfaces, but only some. Where is one of them. The next thing I want to show you are high order functions. And these are especially fun because high order functions behave like objects. You can save high order functions in, that's not the right slide. We already had high order functions, it's basically passing parameters in. This is an example where first we have this function at the top, and it doesn't really matter if I'm using it as a lambda or as a function reference. The first one here is a function reference. We define the test4 plus rating function and then passed it in, or we can use the function basically inline. It's the same thing. Now we go to functions as first-class citizens. And this is the cool part because now functions can behave as objects. We can store functions inside of objects, so meaning inside of variables, but we can also store them inside of data structures like maps and lists. It looks like this. We have, again, our function here. This is just a function, and we can save it as a variable. Cool. And we can also save a list of functions. Also pretty handy. And this is only possible because Dart allows us to do this. That functions are actually first-class citizens is not that very common in programming languages. So a good thing that we have this. And together, using functions as first-class citizens, being able to store them in data structures basically, and using the high-order functions, we can very much improve our example code that we had before. So let's head back to our sort product function. We want to remove all this compare to stuff. I reduced it here, but we will get rid of it completely. What I want to do to make it easier to follow is instead of writing a switch case here, which is fine to use, I want to write an if-else because that makes refactoring a bit easier. It looks like this. This is boring code. It's just 2 nested if-else, and it goes on and on for every additional sorting field. Let's focus on these lambdas here. Both are using or are passed into the copy sort function. And they have the same signature. These are basically the same, from an outside perspective, the same functions. So we can extract those into a variable. Let's create a new variable at top. I call it compare. And instead of passing those lambdas directly into the copy sort function, we first store it in a variable and later only once call the copy sort function, our sort products function here. Okay, now that we did this, now is the hard part. Okay, watch closely. We now extract those lambdas into a map. It looks like this. We have a map at top which tells us, oh, you want to sort by rating? Cool. Here's a lambda that basically sorts by rating. And so on and so forth for all the fields. And look closely. If you want to sort by discount, we have the same lambda here. So we now have map on top which saves lambdas that tells us how to sort things. And at the very top, at the bottom, we have those same lambdas. This means we can replace those, and we can replace this by just a single call. We call our map and pass in the sort field, and we get a function as a return value. High order functions, and we can save this function and then call the copy sort method. It's just 2 lines of code. Of course, once we have this map on top, but this is quite easy to create and write, and also easy to maintain. So we reduce our sort products function quite a bit. If you watch closely, you already noticed that I forgot the reverse order. That can be easily done. So I can implement a reverse function that reverses a function. So I write this as an extension here. What it basically does, the compare function has 2 parameters, A and B. I just swap them. And then the compare function does the reverse. So because I can call this on a function, I can use whatever compare function I get, one of them at top, and reverse the order there. I quickly shuffle things around because, as I already said, the code at the bottom is not something that we really care about. If you would review the code that I've written, you would most likely just focus on the sort product function. And it also makes it easier to compare the first solution with the other solution if you ignore that at the bottom. But that's another reason why I basically would not like to focus on the source code there at the bottom. And that's because we can replace this with existing functional programming libraries out there. I just pasted in 2 libraries. This is the Dartx library and the KDart library, both because they are not really functional, but they have some functional functions in them. And instead of, I can replace a few things. So for example, there's already an existing compare by, there's an existing compare by function, which takes a selector. So instead of basically having a map at the bottom where I pass in the actual compare 2 functions, I only say I want to pick this field from object. This is my selector. And then I have the compare by function, which takes in selector, and this returns comparator. So this way you can build up multiple functions and chain them, mutate them, not mutate, transform them however you want. The reverse function is a built-in thing. I previously wrote this myself, but this is a built-in thing. And also the list.unmodifiable. I can remove this if I use a function that returns me a copy already. And I think this function is from Dartx. There's a sorted with function which already returns a copy. It's a pure function. So I reduced this code quite a lot. And now we have to compare it to the previous solution. And you might argue, yes, this one is shorter. It's quite easy to read. But this one, you're probably right, but we won a lot of things. First of all, the new function we created is super easy to test. 3 input parameters, 1 output. It's trivial to write unit tests for those. Also, the pure function cannot be flaky at all. If you ever had flaky tests, it was mostly because of some mutable global state. We don't have this with our pure functions here. It's super easy to debug. I told you before, you can see all the values while you step through. There are always only copies. There's never some mutation happening. You're never losing data. And it's also very easy to refactor. Think about this, refactoring this and replace all the compare 2 functions with some other functions and add another function, add a 3rd sort order. It's quite complicated and takes a lot of time because of manual steps. Whereas you have a function like this, it's probably easier to implement something new there. What we haven't talked about, but pure functions are thread safe, which is not a big concern in the dark world because our code is running in an isolate. It's already a single thread of execution. To run code in parallel, you have to spawn an isolate. But pure functions can actually spawn isolates. It doesn't stop you from spawning isolates. You don't have to refactor a whole lot of stuff to be able to spawn isolates. You can just do it and use the functions there. Let's wrap this up. Is Dart a good choice for functional programming? Again, Dart is object-oriented at heart. Probably, yes, as I told you, there are many things you can learn from functional programming and apply it in every language. So yes, you can absolutely use some concept of functional programming in Dart. But you probably will not be able to basically write pure functional programs in Dart because it's not a functional language and it's not designed to do that. But it's coming soon. Let's talk about some language features that help us implementing functional code in Dart. First of all, functions are first class. That's great. We have support for one-line lambdas, which is good. After I learned that this was coming pretty late to the JavaScript world, and they were still celebrating it today. And we have at least immutable references. We have the final field or the final modifier, not immutable data structures, but hey, we have generics and extension functions. Great. And we have type inference. We have strong typing in Dart. Also nice. What's not so nice, no immutable data collections. There are third-party libraries out there, but it would be great if they were first class and officially supported by Dart and Google. We have no algebraic data types, no sum types, unfortunately. If you don't know what it is, basically, you can say, you can mix two types together, like, hey, this can either be a string or a double, pass in one of them. This is not possible with Dart. If you want to have a function that takes both types of parameters, we have either to go dynamic or create two functions. A bit sad. We have no pattern matching, but this is maybe coming soon. And unfortunately, and this is the biggest downside of Dart is that the Dart core library has a lot of functions which have side effects, and a lot of them also throw exceptions, which is another side effect. Exceptions are not return types, so this is a side effect. And also, if you're looking at other languages that came out recently in the last 10 years, they have smaller lambdas than Dart. But Dart lambdas are quite verbose, which is annoying if you write a lot of functional code. So what's the future for Dart like in functional way? Pattern matching is eventually coming soon. It is in the spec phase. This means after it left the proposal space. It is now a language feature that is in specification. Long proposals for this. You can follow everything open source. A good thing about Dart. And it covers a lot of things. So for example, multiple return values, structs, records, whatever they actually name it in the end. Algebraic data types. Hopefully they will implement it. Pattern matching, fantastic. That will basically solve all my problems, and I don't have to use freeze anymore to use unions. Sum types and all that stuff. Eventually that's coming. The spec was written like almost 2 years ago, and I hope they are soon doing it, because the next big thing is at the very top, the static meta programming. And then are some smaller language features, and then pattern and related features is the next big thing. So hopefully once static meta programming is released in the next year, they start actually working on patterns and more functional stuff. Take functional programming as like a new tool in your toolbox. Yes?
It's actually a question of your list, but I can wait until you're finished.
Okay, give me a second. So yeah, functional programming is just a new tool in your toolbox. Use it when you can. It will solve probably some of your problems. But OOP features, all the stuff you learned about OOP, use those as well. I mean, those are not quite that bad. Take one thing from me. Please start today by using immutable objects and collections. Write pure functions. And once you implemented all this and you're quite happy, thank me later for that. And I have to thank you for listening. Thank you.